So we're interested in the liver fluke parasite. So this is probably the most, or one of the most problematic parasites that we see in cattle and sheep here in Wales, the UK, and probably around the world as well. It can be very devastating, causing production losses, so animals becoming less productive, severe welfare impact as well, causing disease in animals, and even in certain instances mortality as well. So it's a parasite that is really taking advantage of climate change. It's becoming more common. We're also seeing drug resistance. So traditionally farmers would be using drug treatments to keep on top of this parasite and control it, but unfortunately now it's evolving, the parasite, and it's able to survive in a lot of cases the common treatments that we would give animals against it. So we need to be rethinking really how we're controlling it, and that's what we're doing, really looking at maybe alternative ways of controlling it, with quite a focus on what's going on in the environment of the farm. The liver fluke has got quite a complex life cycle, which makes it quite unique really. It has to infect a snail, a mud snail usually, before it can develop and then infect your cow or your sheep. So that gives it an advantage because in that snail it can multiply and it can develop. But also it's a weak point as well because it's so reliant on this snail that actually if we can maybe target the snail, then we can also target the parasite itself. The snail is quite sensitive. It will only live in certain areas, and because of that it's only in certain areas on a farm that this parasite can infect. Obviously some farms will have a lot of these snails and then a big liver fluke problem. Other farms may not have any of these snails living there, or maybe small populations. But what we find is that the understanding, or our understanding as academics, vets understanding, farmer understanding, is a bit limited at times in terms of knowing where these snails are present, what factors maybe determine where they're found, and so a lot of the research that we've been doing is to look at the snail, look to see where it's living on farms, what sort of factors might make its presence more likely or less likely.
Over the past 2 years we've been to 16 farms and we've been collecting snail specimens, particularly the snail Galba truncatula, which is an intermediate host for the parasite liver fluke. We've been collecting water samples, and also we have been talking to the farmer about how they control liver fluke on their farm. So then back in the lab we've been processing the water samples, looking for DNA from the snail and also the parasite liver fluke, and also looking at the DNA fingerprinting of the snail, which will help us determine the movement of the snail between habitats within farm. So taking water samples on farm to look for environmental DNA is useful for the farmer because sometimes you cannot find the snails by hand. They're very small to see. So we're gaining this knowledge, and from that really we're then hoping to share that information with farmers, with vets, through knowledge exchange activities and so on, so that farmers have a better understanding then of where their animals are getting infected, and where we can then put practices in place that mean that the animals are not infected or infected with lower levels in the first place. Reducing hopefully the infection status of your animals on farm to liver fluke, you will increase your profitability. You will be able to hopefully reduce the use of anthelmintics, which there's resistance to currently, and it will improve the animal welfare and it will improve the environmental impact of farming.